Okay, so let's have a little bit more fun with inverse trig functions. So we've looked at simplifying things like arc sine of theta, and we saw it was kind of complicated. We had to break it up into the different quadrants and see what it comes out to be. Same thing with arc cosine of theta and arc tangent of theta, right? But now I want to do another example. I want to do arc sine. Oh, you know what? Let's do this actually. So let's try computing cosine of arctangent of how about um, -1, something like that. Cosine of arctangent of -1. Now, there's a couple of different ways we can go about doing this. Okay. So here's one way. This is approach number one. Oops. Approach one. Okay. So arctangent of -1. Let's just go ahead and evaluate that. Right? That's where it's an angle theta such that tangent of theta is equal to -1, right? So that's going to happen at negative pi over 4, right? So arctangent of -1 is just negative pi over 4. Okay. And then now that we have that arctangent of -1 is just negative pi over 4, well, then cosine of arctangent of -1 is the same thing as cosine of negative pi over 4, right? And then cosine of negative pi over 4 is, well, I mean, it's even, so then that's the same thing as cosine of pi over 4, which is square root of 2 over 2. So there we have it. So cosine of arctangent of -1 is just square root of 2 over 2. So we can do it that way. That's approach one. Okay. Now, we were able to do that just because -1 is one of those special values for tangent, basically. Tangent of theta is equal to -1 at one of our special angles, I should say, right? And we only have those 16 special angles. If I had chosen a different value altogether, right, there's no saying that we could evaluate the exact value of arctangent of that thing, right? So I'm going to show you another approach right now. Okay. So starts off very much the same way that we would do this before. So I'm going to let arctangent of -1 be theta, which is the same thing as saying that tangent of theta is equal to -1. Okay, so now I have tangent of theta is equal to -1. Great. Okay, so now that I have that, right, now, well, tangent of theta, right, equals -1. That's fine. But we know some things about this angle theta, right? Arctangent, the range for arctangent is negative pi over 2 to pi over 2, right? So I should say that let theta be equal to arctangent of -1 with theta between negative pi over 2 and pi over 2, right? Because those are the only things that we could get out of arctangent. Okay, so that means that this angle theta has to be either in quadrant 4 or in quadrant 1. Okay, now, since tangent of theta is -1, which is less than 0, so our tangent is negative, this means that theta lies in quadrant 4, right? It has to lie in quadrant 4. So I'm going to go ahead and draw this angle in quadrant 4 then, okay? So I'll put some axes over here. I'll put my terminal side, let's say right there. Okay. And then now, right, this is my angle theta. You can draw it any which way, right? Okay. But the important thing here is that we need to find a point that lies on this terminal side, right? Which of course it has some x coordinate and some y coordinate, right? It also has some distance to the origin, r, which is computed by square root of x squared plus y squared. Okay. So this is very much like an exam one problem. Okay. We have tangent of theta is equal to -1, but tangent of theta is equal to y divided by x. So y divided by x has to be equal to -1, right? Because tangent of theta is -1. But we need to express this as a fraction. Okay, so I'm going to write this as -1 divided by 1, where I'm putting the negative sign in the numerator, because if we're in quadrant 4, our y value should be negative. So this means that my x value will be +1 and my y value will be -1. Okay. And then now that I have my x and my y value, I can compute my r value, square root of x squared plus y squared, which is square root of 2. So now I have my r value. And then now let's recall that I'm trying to compute cosine of arctangent of -1, okay? But arctangent of -1 is what we defined to be theta. So then I'm trying to find cosine of theta, which is just equal to x divided by r, which is just 1 over the square root of 2, which is just square root of 2 over 2. So we get the same thing that we had on approach 1, right? It seems like it's a lot more work than approach 1, but that's just because of that arctangent of -1 happened to be one of our special angles that we could do that one so quickly. Let's try a different one, though. Let's say I want to compute, how about tangent of arc cos, sorry, I said that backwards here. Arctangent of cosine of, oh, no, sorry, I had that backwards. My mistake, everybody. Let's try computing tangent of arc secant. Ooh, that's a good one. Of, how about 3. Yeah, tangent of arc secant of 3. Okay. So we can't do approach 1 on this one because arc secant of 3 is not one of our special angles, so we can't find an exact angle on it. So instead, we're going to do approach 2. So let's let theta be equal to arc secant of 3, which, if you'll recall, you don't need to know anything about arc secant except that this is the same thing as arc cosine of the reciprocal of the thing on the inside. So this is the same thing as arc cosine of 1/3. Now, this is the same thing using my inverse property as saying that cosine of theta is equal to 1/3. And let's recall that the range of arc cosine is 0 to pi. So my theta here has to be between 0 and pi. Okay, no problem. Okay, so now that I have that, well, since cosine of theta is positive, right? Well, then that means that my theta is in quadrant 1, right? I mean, it could be in quadrant 1 or quadrant 2 because of this, right? Yeah, but now since I know that cosine of theta is positive, that means theta has to be in quadrant 1. So I'll go ahead and draw my angle here in quadrant 1, right? Maybe I'll draw it that way, sure. Okay, we need to find a point on here, x, y, and of course there's an r, which is equal to the square root of x squared plus y squared, okay? So we know that cosine of theta is equal to x divided by r, okay? But we also know that cosine of theta is equal to 1/3. So then we can say that x is equal to 1 and r is equal to 3. And then to find y, well, x squared plus y squared equals r squared. That's equivalent to this, right? So I can plug in my x value. So that's going to be a 1 squared, y squared equals 3 squared. So I'm going to get 1 plus y squared equals 9. So y squared is equal to 8, which means that y is equal to either plus or minus the square root of 8, which is 2 square root of 2. Okay. Now, since we're in quadrant 1, we know that this has to be positive 2 square root of 2. So now we have our x and our y and our r, and we're trying to compute tangent of arcsecant of 3. Okay, just to make sure there. So tangent of arcsecant, let me write a little bit neater than that. Tangent of arcsecant of 3 is the same thing as tangent of theta. We define theta to be arcsecant of 3. So then tangent of theta, well, that's just equal to y divided by x. Okay, so that's going to be 2 square root of 2 divided by 1, which is just 2 square root of 2, an exact value.